15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you so much for joining us on yet another episode of the Space Nuts podcast. They just seem to meld into one another, so we'll just call this episode Infinity, or it could be episode 221. My name's Andrew Dunkley, your host, and with me, as always, is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hi, Andrew. 221. Who could believe it? We could ramble on.
I didn't ever anticipate we'd get this far. I thought we'd do 2 or 3 episodes and people would go, oh, it's rubbish, and that'd be the end of it.
Well, they still do that.
Yes, they do.
Never mind.
Oh, no, we'll just do it. We'll just be an audience of 2 if it comes down to that. I mean, first couple of years were like that.
Yeah.
Now, today we're going to talk about the Rosetta Spacecraft. It's back in the news because it's detected something emitting or happening with a comet, which you would not expect. I would not think that you would see this when it comes to a comet, but that's exactly what it is, and I haven't explained it because that's your job. We'll also talk about Russia's claim to Venus. Yes, they own it, apparently. Can we arrange for them to move there, perhaps? And they're welcome to it, maybe. And NASA's plans to go back to the moon in 2024. They're talking about putting the first woman on the moon, which I think is fantastic. And we'll answer questions about fuzzy telescope images. Was the universe a black hole when it started? And a bit of confusion about an image on a TV show that somebody has asked about. We'll tackle all of those things today on the Space Nuts podcast. But first, Fred, the Rosetta Spacecraft, auroral emissions is what it says in the headline. That sounds rather fascinating and in an unusual place.
It's extraordinary, that's right. So this is a reanalysis or further analysis, if I can put it that way, by scientists at the Southwestern Research Institute, which is in Colorado, if I remember rightly, who are, the world experts on planetary science of this kind. I think it's where Alan Stern was based when he became the New Horizons project manager. So scientists there have been looking at data from some of the equipment that was flown on board the Rosetta spacecraft, which you and I talked about interminably a few years ago, because that spacecraft was in orbit around Comet 67P, otherwise known as Churyumov-Gerasimenko. Gosh, I can still say it. That's amazing. Which was in orbit around Rosetta. If I remember rightly, yes, it was 2014 through to 2016. So a long period of time. It was when you and I used to talk on the radio that we talked so much about Rosetta. And that so that the new analysis has turned up something completely unexpected, which is that the comet 67P has aurorae. Work that one out.
I can't.
No, they can't. They have done, though, which is good. So it's on the Earth, of course, which is rather bigger than the comet. The comet, if I remember rightly from those days, it's about 4 kilometers across, I think. It's shaped like a rubber duck. That was the joke when the spacecraft was approaching it, because all we could see was this rubber duck in space. Very common morphology. It's actually 2 chunks stuck together, and the gravimetric measurements demonstrated that were made by Rosetta. So the comet, much smaller than the Earth. The Earth has a magnetic field. The comet doesn't. And we are all familiar with the idea that the magnetic field lines at the Earth's magnetic poles are where the subatomic particles from the sun are accelerated, they spiral down the field lines and interact with the atoms of the Earth's atmosphere, and essentially cause this the beautiful phenomenon known as the aurora. Don't get me started on the aurora, because I can wax lyrical
so spectacular.
Yeah, for months and months. They are fantastic. But how do you get the same thing happening on a comet? And so in fact, it was the emission, the light itself, that was detected at first that sent them up the wrong path. So one of the scientists, whose name is Joel Parker of SWERI, said, initially, we thought the ultraviolet emissions at Comet 67P were phenomena known as dayglow, a process caused by solar photons, that's the particles of light from the sun, interacting with the gas of the comet. And we should just clarify that the comet itself has, the comet is basically a flying iceberg, but around it is what's called the coma, which is the envelope of gas that has been released from the comet's surface as it gets nearer the sun. So what they were thinking was that initially they thought that it was the photons of light interacting with the gas of the coma that formed this dayglow, the ultraviolet emissions that they could see. But using more than one instrument, one of them is called ALICE, which was the spectrograph that was used, the ultraviolet spectrograph. But there's another instrument called the Ion and Electron Sensor, IES, which was also used, and it was that turned up the smoking gun, that actually these emissions are not dayglow because they're not caused by particles of light from the sun, but they're caused by electrons from the sun, which is the solar wind itself. So he went on to say, or Joel Parker went on to say, we were amazed to discover that the ultraviolet emissions are aurorae, driven not by photons, but by electrons in the solar wind that break apart water and other molecules in the comet and have been accelerated in the comet's nearby environment. The resulting excited atoms make this distinctive light. So it's not clear to me how they are accelerated. I think what happens is that the electrons from the sun, which are piling along, we're feeling them all the time here in the Earth's environment, they hit the water. Let's just take water because that's the most common molecule that's emitted by the comet because it's mostly ice. The electrons hit the water molecules. The electrons, I should make it clearer, in the solar wind. They hit the water molecules which are in the comet's corona and break them down into hydrogen and oxygen. And it's basically the fact that you suddenly have individual atoms of hydrogen and oxygen that actually cause the aurora to glow. There's some sort of excitation process which I haven't really studied in enough detail to comment on, but it basically was a surprise that it wasn't just what they call dayglow, just a fairly mundane form of excitation of light from the comet, but actually this process that involves atoms or molecules being knocked apart that causes the auroral glow. So a remarkable discovery.
Yes, indeed. So if you were flying alongside the comet while this was happening, would you see it like you see it standing on Earth? Would it be that obvious?
No, it wouldn't. Partly because it's in the ultraviolet region of the spectrum, so you wouldn't see. It's not invisible light. Just reading a little bit more about the process. The bottom line here is that when the molecules of water, the molecules of water that come from the comet, when they're broken up by these electrons, when they're broken apart to hydrogen and oxygen, those atoms are themselves in an excited state. That's the crucial bit that I was missing before. Those atoms themselves are excited, and they de-excite by releasing ultraviolet light. So what you've got is the impact of an electron that is converted to the ultraviolet light, and that process is what causes an aurora. There you go. We got there in the end, Andrew.
Wow. But the last thing you'd expect a comet to
be
doing. Yeah.
Just a loose end that, of course, Rosetta was, I don't think I mentioned this, a mission of the European Space Agency, one of their really successful flagship missions, which is why we're still talking about it 4 years after it, after the spacecraft. I think it actually wound up landing on the comet, didn't it? That was what happened at the end.
I believe so, yes. Indeed, yeah. No, it's a fantastic mission, and it's good that they're still gathering data because that's what you want from a mission: a bit of longevity and a bit of extra information, things that you don't expect. Always very exciting. And let's just move straight on to the next topic, which has certainly hit the news this week, and of course the tabloid press, as always, have nailed this one down pretty quickly. I did actually search through the list of stories associated with this to find a credible source, which I sent to you. But Russia has laid claim to Venus.
Yeah, well, that's right. Yes. So what we're talking about here is, we've talked about the phosphine in the atmosphere of Venus. If I remember rightly, we might have talked about that last week.
Indeed.
I spent all last week talking about that, so I'm sure you and I did as well. So the day after that announcement was made, the president of Roscosmos, the Russian space agency, which is actually, I have to say, it's a top-notch organization. It's not a fly-by-night organization at all. They are big players in the International Space Station, so it's very much one of the global players in space activities. But their president, Dmitry Rogozin, I think is the way his name is pronounced, said something to the effect that Russia believes that Venus is a Russian planet. And apparently he also said that the United States once called Venus a Soviet planet because when the Soviet Union was the dominant political force in that region, that is when the various spacecraft were sent to the planet Venus. And so it's, in many ways, it was very much a focus at the time by the Soviet Union. My reading of that is that this is nothing that we should worry about. I don't think what they're trying to do is declare ownership of Venus, partly because that's illegal.
I was going to say you can't, can you?
Yeah, you can't. Russia is a signatory, of course, to the International Space Treaty and all its ramifications, and that says nobody can own anything. The latest versions of that, though, say that if you bring something back from somewhere, then it's yours, but you can't actually own the place itself. So you can't own Venus. And the other thing is that Venus was last involved. Sorry, Russia was last involved with Venus in 1984, which is quite a long time ago. So maybe the presses have gone cold on that.
Yeah.
So
I think they're just stirring the pot a bit, aren't they?
I think that's what it is. I don't think it's a particularly serious comment, but it'll be very interesting to see if it does go further. You could say to some extent that Mars is American because there's far more American hardware, NASA hardware on Mars than any other nation. There's a few bits and pieces of other nations' attempts, but all the successful stuff has been done by
maybe Russia was just getting a bit jealous that they're kind of out of the astronomical news these days. It's all China, the United States, India, European Space Agency, JAXA. They're all getting the headlines.
Yeah, that's certainly true. They are the headline things. But it has to be said, Russia is still doing great things in the collaboration with the International Space Station. So, they shouldn't feel out of it. They're doing
No, definitely not. And of course, the private operators are getting a lot of headlines these days too. One more thing, going back to our previous story about Aurora, I read this week, just a totally unrelated thing, there is a new report suggesting that the sinking of the Titanic could have been worsened by the Aurora Borealis. They have now discovered that the Aurora Borealis was visible that night. It's in the captain's log of the Carpathia, and they think the geomagnetic effect may have disturbed the distress signals from Titanic, and the ships nearby may not have ever heard their signal, even if they could. Even if they were listening. So that's a really interesting little discovery that has been put in a report this week. Whether or not it holds water, no pun intended, remains to be seen, but it is a pretty solid theory by the sound of it.
I saw the headline, Andrew, but I've been so busy this week I didn't have time to follow it up, but I'll have a look at that and let you know what I think next week.
Yeah, I'd love to follow that up because it is a fascinating theory. All right, you're listening to the Space Nuts podcast. Andrew Dunkley here with Professor Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments, and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, I must send out an apology. We have been guilty of not adding extra material to our Patreon platforms lately, and that's just that's on me. Time is against us. Fred and I have been kind of under the gun lately. I don't know why, but that's just the way the world is sometimes. But very soon we'll track down some Patreon type questions and add them to the bonus material that we do offer our patrons. And if you'd like to become a patron, there are quite a few ways of doing it. You can go to the Supercast website and find us there and sign up for a package deal, or you can go to patreon.com/spacenuts and sign up for whatever amount you deem worthy. I mean, it doesn't have to, it can be as little as $3 a month, I think. That's US. Or you can go to our platform, Acast, and they have a donation portal. But it's totally voluntary. We never, ever will tell you have to do it. We will never put a price on Space Nuts for everyone to have to pay. If you so desire, it is up to you, and we certainly appreciate it. And, that is fantastic that you want to put some money towards the podcast, but it is absolutely and utterly voluntary. So thank you again to our patrons, and we'll get some bonus material in there for you soon as we can. Now, Fred, let's move on to our next story. This is exciting as well. I mean, we talked about Russia claiming Venus and that America should probably lay claim to the planet Mars, but no, they're focused on the moon, and NASA's just published its plans for 2024, going back.
That's right. This is the Artemis mission, the flagship mission of human spaceflight for the next few years. We'll hear a lot about it. This is the equivalent of Apollo, very much so. And in fact, in many ways, it resembles Apollo, but with modern hardware that really is 21st century rather than mid-20th century. So what's the story? Well, as you said, NASA has announced the schedule for putting the next man and the first woman on the moon by 2024. It's Jim Bridenstine is the NASA administrator. He's been the person who's set this or been the front man for setting this all out. As we've solidified more of our exploration plans in recent months, he says, we've continued to refine our budget and architecture. We're going back to the moon for scientific discovery, economic benefits, and inspiration for a new generation of explorers. As we build up a sustainable presence, we're also building momentum towards those first human steps on the red planet. So the schedule that's been laid out, I think, is still pretty ambitious, Andrew, but involves the Space Launch System, which is the new rocket system that will actually take astronauts to the moon. And you might remember that's a sort of, in many ways, it owes its origin to the space shuttle, because the booster rockets that we use to launch the space shuttle are also, I think they're now upgraded, they're new improved versions, but they're the same booster rockets that will be used for the Space Launch System. And then there's a core space vehicle, which again uses engines. I think the core stage has 4 engines. The boosters are solid fuel rockets. The core stage has, I think, hydrogen, oxygen fueled. I think there are 4 engines on that core stage, and these are all apparently in the final series of tests at the moment. They're talking about a critical hot fire test this fall. Fall, of course, being springtime here in Australia, but that's exciting stuff. So once that hot fire test has been done, the core stage will go to the Kennedy Space Flight Center in Florida to be integrated with the rest of the spacecraft, and there will be 2 test flights actually going around the moon to check that everything works. The first one, Artemis 1, on track for 2021. That is next year, Andrew. So we'll be seeing an uncrewed mission to fly around the moon with all the hardware that will actually carry astronauts there, but nobody on board. That will be next year. And then Artemis 2 will build on that. It'll do the same thing. It'll be a translunar flight, but with a crew on board. And that is expected 2 years later. So 2023, we should find a kind of equivalent of Apollo 8, which was that was so emotive when Apollo 8 was successful in December 1968. Christmas Eve, they were going around the moon, astonishing stuff, and absolutely riveted the world. So if it's anything like that in 2023, I think that will be great. And then building on that, this all then depends on the commercial sector coming in, because the commercial sector, and I'm sure SpaceX are involved with this, and I think Orbital, although Orbital isn't called Orbital anymore, I think there are other companies that are building equipment, might be Northrop Grumman. Sorry, I've got all these companies mixed up in my mind at the moment, but commercial delivery services, and they will send basically hardware to the moon, landing on the moon, and this will start again next year. Twice a year, they're talking about landing stuff on the moon in preparation for the 2024 Artemis 3 mission, which will be when humans return to the surface of the moon. You can probably hear there's some magpies cheering us along outside my door.
I can hear them. We've got a lot of them around Dubbo at the moment. It's not a time of year to be outside with a magpie either.
Oh, but they get
a bit vicious this time of year.
But they are wonderful birds. Anyway, the Artemis 3 is destined to land the first astronauts on the lunar South Pole. So it will be, basically a mission that will put them into lunar orbit, and then they will. There's still some uncertainty about the exact configuration that will take place for Artemis 3. I think what the hope is, though, that they will dock with the Gateway module, which you and I have spoken about before. This is almost like a mini International Space Station, which will be in orbit around the moon. And it's a kind of a staging post to gather supplies, to check everything's working all right, and getting on board the landing system, whatever that is.
Finishing off the games of Yahtzee before they go down onto the surface.
Yes, that's right. All of that. That's right. What do they have to do? So yeah, it's it's very, very exciting that in the next 4 years we should see a really remarkable access to the moon. They are talking about 7 days on the lunar surface.
Really?
Yeah, longer than what we had with any of the Apollo missions, and then back to using the lander. So the lander does not go with them from Earth. It's there already because it's been placed there. Unlike the Apollo lunar modules, which flew with the Apollo astronauts to get them down to the moon, get them back to the command module, and get them back home, these components are all going to be delivered there robotically. So there'll be a lander that will take them down to the moon. They will go back up to probably the Gateway module to have a shower and change and things like that, and then get back to Earth on board the Orion module. The Orion, of course, being the equivalent of the command module in the Apollo era. So remarkable stuff, really remarkable.
And somebody out there, Fred, whose name is unknown to us at this stage, is going to become incredibly famous as a consequence of this, as the first woman on the moon.
Exactly.
I think that's going to be extraordinary.
Yes, that is an amazing thought. And that person is already wandering around, probably somewhere in NASA's headquarters or something like that. Great stuff.
Yeah, they probably have a group of candidates that they're considering at the moment, and they're going through a process of selection. Or they might not have started yet. We've still got a few years up our sleeve, but I think they'd have some ideas at this stage. But, we wish them well. And I think it'll be as exciting for people of today that weren't around for the landings on the moon 50 years ago to witness this again. And it's just an extraordinary thing to achieve, to be able to move, go to another body in the universe, even though it's the closest one to us, and go for a bit of a walk and, even drive a car, which we've done. We've done. And I might point out, you mentioned Apollo 8. If you go to NASA at Cape Canaveral, they still have mission controls set up for the Apollo 8 mission, and you can actually re-witness the launch process as it happened. You can hear the whole thing while you're looking out over the control panels, and everything lights up as the different sequences.
Great. Yeah,
it's really quite enjoyable to watch. And I will also mention a TV series that I'm watching at the moment called For All Mankind. I don't know if you've heard of it. It's an alternative history series where the Russians were first on the moon.
Okay, that's interesting.
It's really fascinating. And I won't say much more. I don't want to spoil it for anybody.
No, the Russians, of course, were developing their N1 rocket, which was the equivalent of the Saturn V, but very different in its architecture and ultimately a failure. Very, very sad.
Yes, and that was the difference in the end, I think. But yeah, it's a good series if you want to look it up. It's called For All Mankind, and I've had people pestering me to watch it. So I finally got down to it, and I'm really enjoying it. They portray the American disapproval of the Russian success very, very well. There's nothing they can do about it. It's brilliant. But they've got other plans, of course. You're listening to Space Nuts, the podcast, episode 221. Andrew Dunkley here with Fred Watson.
0G, and I feel fine.
Space Nuts.
You're listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson, and thank you for joining us. And don't forget to tell your friends about us. If they've got their favourite podcast distributor, they'll probably find us because we're on just about everything, and that includes YouTube. And we in fact, received a question from somebody on YouTube this week, which we will tackle shortly. But I will remind you that if you do want to ask us questions, you can certainly email them through via our website, bitesz.com. /space nuts, that's bitesz.com, or you can message us via Facebook, or you can ask your question yourself through our website, which is spacenutspodcast.com. Click on the AMA link and you can just press the record button if you've got a device with a microphone. Most people know how to use microphones, unlike one particular questioner last week who couldn't figure it out. Oh, I did promise I'd never go back there. Anyway, it's all in good fun. I'm glad I know how to use a microphone. Otherwise, my 30-year career in radio would have been very short. But yes, you can ask questions directly of us, and we love hearing your voices. Now, Fred, we do have a question first up from Ralph Haney. This is a bit of a long question, but it's one you wanted to tackle because he wants to know why his telescopes go fuzzy. Here's Ralph Haney.
Hello, Professor Watson and the venerable author Andrew Dunkley. Very amateur astronomer here. Can you please clarify for me a basic astronomical point? While looking through my 6.5-inch Cassegrain telescope, I see Jupiter with its multiple moons and wonderful clarity. Every night I see orbital changes, making it all the more interesting. Saturn, too, is so fascinating through a telescope. However, as I attempt to zoom in with higher power lenses, I lose clarity, and even though I see a much larger Jupiter, it's a fuzzy white ball no matter how hard I focus. I remember reading somewhere that this has to do with the amount of actual information that is collected through the telescope versus the amount of power. In other words, the strongest optical telescope in the world won't help if it doesn't gather enough light. On top of that, as a Neanderthal amateur, every little bump to the tripod interferes with the experience, and Earth's speedy rotation doesn't help, let alone a beer or two. Buried in my garage, I have a 14-inch Dobsonian telescope tube begging for a primary mirror. It's the remnants of a famous Coulter Odyssey telescope, colloquially called a light bucket. I've yet to find a mirror for it, but I can't wait, and I first need to be able to afford it. Do you have any laying around? Question. Once I do install a large mirror in that tube, am I going to encounter the same type of clarity issues, or will I see more detail with much more information gathered? Thank you both so much for the show. I'm a dedicated listener, fellow nut, and sponsor. Ralph Haney, Northern California. P.S. Don't ever change your intro and outro clips. They're absolutely awesome. Listener says it feels good.
Oh, Ralph, thank you so much. You know, actually, someone the other day said, can you change your intro? I find it too fast. I'm very reluctant to do so. I love our intro, and I don't want to change it, so I will fight hard for you, Ralph. Loved the musical accompaniment in the background. Is that one of the kids doing piano lessons? It sounded like that. Now, Fred, Ralph wants to know why his telescope's showing fuzzy images.
Two reasons. There are two things going on here, Andrew, which are both in their own way interesting. Probably what Ralph is having to cope with is essentially what the atmosphere does to light, and that is that the atmosphere is effectively a lens in a sense. It changes the it changes the path of light beams through it or light rays through it, and turns the image of a star, for example, from the perfect point, which it should be in your telescope, into a blob, which is bigger or smaller depending on how much turbulence there is in the atmosphere. It's also that depends on how much of the atmosphere you're looking through. When you're looking at something very high in the sky at the zenith, then you are looking basically through a thinner layer of atmosphere than you are if you're looking down near the horizon, where you're looking through a much thicker layer, and so the conditions are much worse. So that turbulence is one of the causes. We call it seeing, and you measure it by the diameter of a star image, which should be effectively a point source, but we usually say the seeing is 2 arc seconds or 1 arc second, or sometimes in bad situations 5 arc seconds. An arc second, of course, being 1/3600th of a degree. That's the diameter, the apparent diameter of the image. So bad seeing blows things up, and essentially, if you're looking at something like Jupiter or Saturn, it just smudges out all the detail. So that's one cause. And another is related to the physics of the telescope itself, and that is that if you use a magnification that's and there's a number here that comes from theoretical considerations, but if you use a magnification which is more than the number of millimeters in the radius of your mirror or lens, okay, that's so if you've got a 6-inch lens or mirror, as in Ralph's case, he's got a 6.5-inch Cassegrain telescope. That's about 150 millimeters. The radius of that in millimeters is 75. If you use a power more than 75 times, you're magnifying the image more than the telescope will deliver detail, if I can put it that way. It's what's called the resolution of the telescope, the resolving power of the telescope, the amount of detail that it can see. And there's a limit to that. And if you use more than, the number of millimeters in the radius of your mirror or lens, that will basically means you're just magnifying the light. You're not seeing any more detail. That's a subtlety that is probably it's really the lower of the two effects. The atmosphere is the worst part of it. There is another. Let me just add in a third thing. I find this with my small telescopes that yes, if you magnify Jupiter up, you just see a blob, and I find it very hard to see structure, the cloud belts in Jupiter. Sometimes you can just about make them out. I use very small telescopes when I'm playing around, so that's partly why. But often in some ways, you've got too much light. Jupiter's a bright object, and your eye is missing the subtleties because there's so much light there. So sometimes it might help to use a filter. That might show a bit more of the detail. But I think what the problem Ralph's having is actually with the brightness of the turbulence in the atmosphere rather than the brightness of the image.
Okay, there you go, Ralph. Just get up there and calm the atmosphere down. Throw a blanket over it or something.
If we could do that, it would be wonderful. So, Andrew,
or just get out of the atmosphere. That would be a way. That's what
exactly. That's what the Hubble does. Just while you're while we're pausing between our two questions, I've had an email from the person who couldn't do the audio question because it turns out it's somebody I know.
Oh no!
And so what he says is, I'll read out the email. Thanks to Fred for answering my anonymous question on space nuts regarding parsecs versus light years. Perhaps not so many thanks to Andrew Dunkley for broadcasting my comment that I couldn't make the recording of my question work.
He honestly didn't say not to.
No,
and I've always had this philosophy in radio, and it sort of transfers to the podcast. Everything is on the table when it comes to what I say. Everything. Unless you tell me not to, I'm going to use it.
Yeah, I don't think he bears a grudge. This person
I hope not.
Is not the kind of person to bear a grudge. But just to let you know, your comment did not go unnoticed.
Well, I hope not. No, but I've always operated in radio with the philosophy that everything is open slather. If it's I will use it, and over the years it's served me well.
That's how we get away with as much as we do, I think.
Sometimes get away with it, yes. Okay, thanks, Ralph. Let's move on to our next question from Barlow in Colorado.
Hey, so this is Barlow from Colorado. I am curious, and I recognize that this question is dripping with the gooey goodness of theoretical analysis, but if potentially the universe started from a single point, does that mean the black hole in some way? And if so, does that mean that matter can form from a black hole? Is it based on mass? Just kind of generally thinking about that. Thanks.
Okay. Barlow asks an interesting point. The origin of the universe is always the subject of much speculation and debate. And I'm guessing the short form of the question is, did it start out as a black hole, and did matter emanate from this black hole to create the universe? We know there was a big bang. Where does Barlow's question sit in the scheme of things?
It's a good question, because the model of the universe that we use, which is based on general relativity, when you track backwards in time, you come back to a point where the universe was a singularity. It was a dimensionless point, which somehow released the energy that have caused everything that we see around us. And a black hole is a dimensionless point. The two are effectively the same thing, but a black hole is, gobbling stuff up, anything that happens to come near it, because of the gravitational potential, whereas the universe went the other way. So there's clearly some difference here. The two are not the same thing, although, there are people who modeling the universe as a whole. They talk about the event horizon of the universe. That's a term that comes directly from a black hole. It's the point beyond which light cannot travel. I haven't looked into those theories very closely. I think they're fairly speculative. Excuse me again. It also has links, or perhaps connections, with the theories that some other physicists, and I'm thinking here of Roger Penrose, whose work we've mentioned several times on Space Nuts, a mathematician who has, is a very well-known and very eminent physicist, but he's got a model of the universe, which is that, yes, the universe comes from a black hole that becomes unstable. So it is a singularity. It expands, and all the energy turns into matter, and we get a universe, which itself spawns black holes. And we know that happens because we can see them. We see black holes of many billions of times the mass of the sun at the centers of galaxies. Penrose's theory is that these eventually grow so big that they become unstable, and then they form another big bang, and you get another universe being spawned from that. I'm not sure that, it's 10 years or so since I last looked into Penrose's work. I'm not sure how widely accepted that is today, but it might be something I might go and follow up. So thanks to Barlow for raising the question, because it is exactly along the lines that people think about.
Yeah, I suppose with the creation of the universe, you can never say no to everything. There was no one around to observe it. We know it happened. We can see the cosmic background radiation evidence.
Yep.
But, yeah, what exactly happened is still kind of subject to theory and speculation, I suppose.
Although, the problem is that when you get close enough to the Big Bang to be really probing what's happening, physics breaks down because you've got, all these high energies and things of that sort. But we can go a long way towards it. And of course, the future of this kind of study, Andrew, has some promise, because we eventually will be able to use gravitational waves to probe further back into that region which we can't see beyond because of the cosmic microwave background radiation.
That'd be awesome to be able to look further out.
Yeah.
Indeed. So, all right, Barlow, thanks for your question. Now, one more question. This comes from a YouTube listener, Fred Liam Cockcroft. He said, I wish to ask my most learned astronomer at large a question. I'm very confused. Best thing I ever learned about sky watching is following the zenith and look hard for things that don't flicker as much as stars, because the solar system is a disk. Yet in Cosmos, this is a TV series hosted by Dr. Neil deGrasse Tyson, season 1, episode 8, shows the moon very close to the south celestial pole over the Harbour Bridge. And that's the Sydney Harbour Bridge, and the moon doesn't flicker like a star. This can't be wrong, I'm sure. as he spoke at length about how he feels about incorrect star fields in his book in 2007. Gee, Liam, you've been doing your research. Maybe an Easter egg, and he owes me a telescope so I can keep an eye on the South Pole and make sure the moon is not seen there again. Yeah, sure. He's a fancy TV show. I bet your chooks are better than his, though. I mean, it's more of a remark than it is a question, but he brings up an interesting point about the position of the moon.
Well, that's right. And it's, yes, so you can never get the moon near the celestial pole. That's the point. And the celestial pole, of course, in the south, we've got the Southern Cross pointing towards it, and the pointers, many of us know how to find the South Celestial Pole. From there, it's within that region of the sky. The moon never goes there because the moon is in orbit around the Earth and sits in an orbital plane that's similar to the plane of the Earth's orbit. So often you do get hiccups where illustrations are made that show something that is physically impossible. And one of my hobby horses is when people get the moon the wrong way round. So an illustrator might...
Once, didn't we? Wasn't there some major snafu years ago involving that very issue? The moon was the wrong way round. And for most people, they wouldn't notice. But, yeah, somebody did.
Yeah, so that's right. So if you put a graphic of the moon in the, as it's in a scene that's supposed to be the southern hemisphere, and it's showing the moon the way up it is in the north, then something's gone wrong there. And actually, the Crescent Moon is another one. In the evening sky here in the south, the Crescent Moon, it's the left-hand portion that's lit up. But in the northern hemisphere, in the evening sky, it's the right-hand portion that's lit up. And sometimes people get that wrong as well.
Yeah. I can understand the frustration. I'm the type of person that sits and watches TV shows and films looking for continuity errors.
Well, there you go. That sort of thing. That's right.
I can't help myself. And I'll say to Judy, "Oh, did you see that? The shoes changed colour." No. "Oh, I've got to show you." And, "No, don't." I do. I rewind it, say, look. Oh, yeah. It doesn't. I expect a better reaction.
But tell Judy she has my sympathies.
Yeah, it's but yeah, he's brought up a good point. They put the moon in the wrong place, and he noticed, and then Neil's obviously countered that in a book of his. But there's a thing in the industry called creative license, and I dare say that that's what's happened here.
Maybe so.
Yeah. All right. I appreciate the feedback, though, Liam. Lovely to hear from you. A YouTube listener. Don't forget you can listen on YouTube too, if you so desire. We want to get our download numbers increasing on YouTube, so that's fantastic. And that wraps it up for another week. Fred, thank you so much.
It's a pleasure, Andrew. Always good to talk to you, and always good to find out what's going on in the universe, and also hear what our listeners are thinking. It's great to have all the feedback. Lovely to love it as well. Yeah.
Yeah, and keep those cards and letters rolling in, if indeed you want to do it that way. We
whatever you want to do.
There might be an address. I don't know what our address is. I know our email address.
Space Nuts the Earth, isn't it? Isn't that what it is?
Space Nuts Earth.
Yeah,
that'll do.
Yeah,
it'll find us. Thanks, Fred. See you soon. Fred Watson, Astronomer-at-Large, part of the team here on the Space Nuts podcast. And thank you again for listening. Don't forget to tell all your friends, and we'll see you for another episode next week.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.